And when everything is upside down, when you're yelling but you make no sound, life is gonna spin you round. Whoa, and get a little bit stranger. When everything is upside down, a tremor in the underground. The nights are gonna take this town. Whoa, and get a little bit stranger, stranger. Push the kinetics, a troubled spirit breaking through. A bitter debt to repay now. But don't you dread it, a friend would never lie to you, helping you get through the pain now. And when everything is upside down, when you're yelling but you make no sound, life is gonna spin you round. Whoa, and get a little bit stranger. When everything is upside down, a tremor in the underground. The nights are gonna take this town. Whoa, and get a little bit stranger, stranger. Lost in the space set behind. Hold out a hand in your mind. Don't have to face it alone.
Hello, everybody. Welcome to a Wednesday episode of Blazor State Has Changed. Interestingly enough, it seems like every week there is some technical problem that hits me 5 seconds before the show starts. And today it was Windows Update decided to hit me right now for some reason. And it's thrown one of my monitors completely off kilter, so I'm having a hard time seeing the chat and my live feed, so hopefully I can deal with this until I can fix it. Yeah, I don't know why it decided now, and it also messed up my monitor setup. I came back to after my reboot and my start bar was like 3 times too big, and then my OBS, the studio application, is choosing like 7 different font sizes to show me on one screen, so it looks just crazy. So anyway, didn't want to hold up the show anymore and decided to kick it off. So we got about 9 folks in the chat room so far. We'll let a few more join while I chat here with you guys for a sec. Let's go out to Twitter for a second, because we were having an interesting conversation in the Gitter chat room. And I posted a poll, and I'm not sure what topic I should do on the show today. And I'm wondering if we should talk about, and my windows are not snapping because of whatever update just happened, so bear with me here. We had a poll, and not too many people voted, so I don't know if I should change the show topic today or not. I offered to do a little bit of a Razor recap and talk about the difference between Razor components, HTML helpers, tag helpers, view components, all of the Razor universe, and the different variations of it. It's a conference talk that I have that I've had a lot of people show interest in, either directly or indirectly, by just kind of asking a lot of questions about what the differences between these things are. So that poll is closed. But real quick in the chat room, we've only got 6 now. Some people have already dropped off. I don't know what happened there, but the few of you that have joined so far, let me know what you think about doing a conference session, or do you want to see live coding today? we can figure this out real quick, and we'll get on with the show. Hey, On Hip Coder, thanks for joining. If you were just joining me, I was talking about this poll that I put up. Do we want to talk about Razor today and identify all of the different things about Razor, or should we do live coding? We've got 8 votes on Twitter. Poll's closed, but most of it was for the session. Couple in the chat room so far talking about this session. So let's see what we can do. I've got my session. It's been a little while since I've given it, but let's see how well I can do this on Twitch. All right, let's do this. So I have this talk. It's called Razor into the Razorverse. Hopefully you guys have seen the movie. Cool. All right, let's do this session then. So hopefully you guys have seen the movie Spider-Man Into the Spider-Verse. Make sure I got the right view up here. Give me 1 sec to get this set up. All right, just open. All right, good time for a beer. Let's do Razor into the Razorverse. So I built this talk around identifying all the different parts of Razor that exist in the ASP.NET ecosystem. I gave it at Beer City Code, and it's coming to some other conferences this year. It's to kind of shed some light on all of the things that are Razor. So we have Razor tag helpers, Razor HTML helpers, view components, Blazor, all these things that ended up with a Razor name to them. So let's pop over to our coding view because that'll give you the most screen real estate. And I will try to take questions as I go along, but I kind of need my presenter view up on my other screen, so I'm not sure how well I'll be able to handle live questions with this up. We'll see what I can do. Not too bad. I think I can do this. All right. I'll skip the introductions. I think you all knew who I am. At least most of you do. My name's Ed Charbonneau, and I work for Progress. So again, this is Razor into the Razorverse. We'll talk about the differences between all of the things Razor here in just a sec, because the terminology for Razor is getting pretty complex. We've got many Razor things these days. We have the Razor syntax, we have Razor views, HTML helpers, Razor pages, tag helpers, view components, Blazor, and Razor components. So it gets a bit confusing as to what all of these things are. So let's kind of break this down, and we're going to start from the very beginning. And some of this may be a little bit of review. Some of it may be new to all of you. So Razor. Razor itself. Razor is a syntax or template markup syntax. It's based on the C# programming language. So Razor itself, it powers many of the things in ASP.NET, but for all intents and purposes, when we talk about Razor, the syntax, it's a template markup syntax. It was introduced in 2010 by Scott Guthrie, shipped in 2011 with Visual Studio 2010, and the intent of Razor was to improve the templating experience for Razor. And why did we need to improve the templating experience for Razor? Well, this is what we were used to here on the left. This is the web forms syntax that we had. People called this bee stings. We would wrap our for each loops and things like that in a classic, kind of matched up with the classic ASP style. It's a little difficult to read, if you ask me. The things on the left is a little bit unclear as to what's going on with all those different opening and closing braces everywhere, and Razor intended to clear this up because Razor doesn't require an end tag. So you can just open an @ symbol and write your C# code inside of your HTML and not have to worry about these closing tags. If you look at Angular, even, Angular has a lot of specifics to it. This is a JavaScript templating engine, and it has a lot of special Angularisms to it. So we have like ng4 to do a loop, and you still have that requirement of an opening and closing tag to specify your template. So this is why I prefer Blazor, and I think they did a really good job creating this template syntax. Blazor can do a lot of really cool stuff. It can do code blocks, so we can set up C# variables and write them out in a very easy manner. So we can set up something like this, where we can set up a greeting and write that out to the screen using code blocks. We can also write complex expressions out if we surround them in parentheses, so we can add various numbers together. We can do different code functions inside of those parentheses. In this example, we add up the numbers that output a span with 35 in the middle. Blazor syntax can also handle branching, like if statements. There's a lot of control structures. Anything pretty much that works in C# works in Blazor. So we can do try catches, whiles, for eaches, even ternary operators work in Blazor. Blazor also has a concept of directives, and there are a few basic ones that are inherent to Blazor itself. They kind of exist in all of the Blazor ecosystem. So we have our using statements, inherits, inject, and functions. We've seen this may be a little outdated. I probably need to update this one, but functions is now code block in a Blazor component. So we'll see some more directives show up as we touch on the different flavors of Blazor. Blazor components, Blazor complexities rather, rendering. It's generating C# code from the template. So when we render a Blazor component, we're generating C# code from a template. Then we have to compile that C# code into an assembly. So the complex process of rendering is going through all of these steps. Once we compile that code, we have to load that file into memory, and then we have to execute that compiled template. So rendering out Blazor from its template syntax is a very complicated process that we take for granted every day. If we wanted to take the Blazor template engine and use it outside of the MVC ecosystem, that's actually something that is not easy to do. So something we might want to do and think is possible is new up a Blazor view engine and just give it a template that we want to render, maybe from a file path, and get the results of that rendered template. But remember, those complex tasks are very, very tightly coupled into ASP.NET MVC. So there are things that the Blazor view engine is very dependent on, like the view HTML encoder, text writer, and HTTP context. So these are all highly dependent on how that gets rendered. And thankfully, there's a lot of interesting NuGet packages and projects in the ecosystem that have tackled this for us. But out of the box, we don't get that type of behavior. If we go out to NuGet, though, there is a package called Blazor Lite, and it helps with this task of using Blazor outside of ASP.NET proper. So we could do things like new up a Blazor template engine, pass in a template from a string file or some other location, apply a model, and then render that template out. This is super handy for something like rendering HTML emails from a Blazor template, which I've done in the past. Works really well. So that's the Blazor syntax. We still haven't touched on Blazor views, HTML helpers, and so on. So let's start with Blazor views. So Blazor views, or CSHTML files, These are streamlined for code focus templates. So this is helping us build views in ASP.NET MVC. These views are returned from an action, controller action as a view result. And they're made up of HTML helpers, which is typically found in an MVC application. You can also use tag helpers, which is a newer ASP.NET Core feature, and even Razor components, which we'll touch on much later, but this is the bleeding edge of things. To spin up a new MVC application, this has changed slightly over the years, but you select File, New Application, choose Model View Controller. This is where we talk about Razor views the most. You can see even in the project description, we're creating an application with an ASP.NET Core MVC views and controllers. So the ASP.NET View engine has transitioned quite a bit over the past few years, and one of the initial things that it tried to do is offer multiple view engines for the MVC framework. So in the past, we had the web forms view engine. You can still access this in ASP.NET framework, but I think this is gone from Core. I could be mistaken, but you could still inject your own views into ASP.NET MVC Core, but you don't get them out of the box like you used to. So we had web forms in Razor, and you were actually able to choose these from the File New dialog in Visual Studio at one point. You can still switch these out, but it's a more complicated task these days. And you can see there were other view engines that were available at the time as well. Spark and Haml. I've never used either one of those, but Razor ended up taking over, and this is where we get our Razor views from today. Now, the Razor views syntax has its own additional directives. We have the model directive for injecting models into our view or specifying the model type. We have sections that enable us to create specific rendering blocks for our page. This is most generally used for the script section in an MVC view. And then we also got the tag helper, which is something that came with ASP.NET Core. We'll talk a little bit about those when we touch on Razor pages. So I want to talk about how a Razor view is compiled. And for that, I'm going to jump over to Visual Studio for a moment. And give me a second while I find my project that I need for this. Let's close out this solution, and let's see here. Just give me one moment. So I do have a special project here. This should be my sample Blazor app, or this is a Blazor application. I need a regular. Give me a second here. All right, we'll do File New Project. I don't know where that went. We'll do the classic File New Project and pull up an ASP.NET Core web application. ASP.NET Core Web, and we'll just use Web Application 29 here. Whoops, might have hit cancel, create. We'll let this spin up, and we want to select Web Application, Model View Controller, hit create. And once we have our application up, let's go ahead and give it a build. And what we should get is a compiled DLL file that will point to our actual compiled MVC view. And you can see we have the classic model view controller pattern here. What we're focusing on is these MVC views. We have an index page. We should be able to see that if we open up our folder structure here, and we should have a compiled version of it. It's going to be under our bin directory, under .NET Core, and we have web application 29 views DLL. So what I'm going to do is I'm going to open this in File Explorer. And I will check chat room real quick here just to make sure everybody's following on. All right, so we have a standard MVC application, and I have web application.views.dll. I'm going to open this up with a tool called just decompile to see what the tooling has given us. So when we run we compile our application, we actually get a compiled view DLL. And I'm going to skip through these dependencies it's trying to decompile. We don't need to decompile everything attached to the application. We just want to dig into our view DLL here. And we should, underneath of here, have a view that matches our index page. So we have an object here called views_home_index. If we open this guy up and skip again through some of these dependencies, this is our actual index page that was compiled from our view code. So let's go to Visual Studio, open up our index page, and take a look at these guys. So we have some view data being passed in, and then we have a simple div element that displays a welcome message. If we look at the decompiled version of this, we have a class called called views home index, which inherits a Razor page. That's the actual object type that this gets built from. So it's a Razor page of object, and that object is going to be our model. And if we look all the way down at the bottom, let's see if I can zoom in a little bit here for folks. So we can see this really good. If I zoom in down here towards the bottom, we'll notice there is a public override async task execute async. What this does is it actually generates the HTML that gets rendered from that view. So this is the compiled Razor view, and all it does at the very end of the day is generate a string. And you can see that it does a this.writeLiteral, and then it writes out the actual string value, which contains our welcome message and our template generated code. So let's zoom back out. There we go. So our Razor views at the end of the day, they end up getting compiled into a class library or class that matches the same name as our Razor view, and they execute a function that writes out a literal HTML string. So to oversimplify, and this may be a bit of a generalization, Razor views are very complex string generation tools that create HTML strings. So it's very important to remember that that's what they're doing. So that is Razor views in a nutshell. So give me a moment while I adjust my screens again. Popping in and out of presentation mode kind of throws things off. So answering some questions real quick before we move on. It is similar to the Blazor g.cs files. However, there's some differences in the way Blazor handles it. Blazor does a little bit more of code generation. This is more a compile or type of a feature. It's compiling our view into an actual DLL at runtime, it used to do it at runtime. Now it does it ahead of time, but we don't really get a look into it unless we decompile it, where Blazor has the code generation files that we can look into. So they're slightly different. Hopefully the stream is still looking okay. There's some reports of things getting a little jittery, but it looks like we're broadcasting good here. So we'll move on now to the next topic, which is HTML helpers. So HTML helpers are invoked as methods within HTML Razor views. They encapsulate a block of HTML and Razor code. At the end of the day, they produce an HTML string. Sound a little familiar to what happens with MVC views. They are building blocks to MVC views, and they're mainly used with the MVC pattern, and we'll see that there's been new methods to do this introduced with tag helpers. And we get a lot of HTML helpers out of the box, and we write these out as @HTML dot, and then invoke those specialized methods. We can create links. We have radio buttons, text areas, forms, and all sorts of things that help us build out our HTML for our Razor views. So this is what an HTML helper looks like. If you're not familiar with an HTML helper, they start with the @ symbol, and then you invoke the @HTML dot and your helper name. So this is an extension method that we're running, and we're going to write an action link. We pass in a set of values, and we get back a string of HTML that has our route and the text that we wanted to display in our link. HTML helpers are pretty easy to create. We can create some simple HTML helpers. We can also create complex HTML helpers that take a little bit more time and effort to engineer. But the simple stuff we can create pretty quickly. We just extend iHTML helper as an extension method, and this is a method that returns an iHTML content. This has changed a little bit from MVC to core. This used to be just the instance HTML content. Now it is the interface HTML content. So if you're doing any migrations from framework to core, you might find that little bit tripping you up. So creating custom HTML helper, this is what the function signature looks like. It's basically a function that takes an iHTML helper and returns iHTML content. So using an extension method, we're going to pass in the iHTML helper and then extend that. I did this at Beer City Code, so hence the method name here. We have iHTML content, and we're giving it a method name called Beer City, which returns iHTML helper, which takes an iHTML helper as an extension method. That's what this statement is for. It's identifying that this is an extension method that extends iHTML helper. Once we have that, we can write a new HTML string and encapsulate whatever HTML we want in there. For more complex HTML helpers, we have tools to help us build out the complex HTML. But when you return that final function, they are returned as an HTML string. We're going to do a quick demo with the HTML helper. I'm going to try and find this project again. I have something preset, and I seem to have misplaced it earlier. So let's see if I can get that up here. Real quick, just give me 1 sec. Let me drop down to my file explorer and do a quick search on this, because I have a really great example if I can find the demo. There we go. This is what I'm looking for. And I should be able to pull this up. There. Much better. So we're going to take a look at how to create a custom HTML helper real quick. And we will also decompile that and see how it looks. So again, this is an MVC or model view controller application. And we have a C# class file here, and it is a public static class. It has to be static because all of the methods will be of a static type. This one is called Beer City Code because that's the last place I gave the conference talk at. And it has a static method in it that returns an iHTML content. So we have our Beer City method. It extends an iHTML helper, and it produces the HTML string, which is an image that has the conference logo in it. And then once we're on our view, we can simply type, I've got it right here, but I'll type it again so we can see the IntelliSense come up. This is @HTML, which gives us a list of all of our HTML helpers available. And we can just say Beer City. That's the method we gave it. And we don't have any parameters to pass our method, but we could pass parameters if we had them. So this will write out an image tag with the Beer City Code logo in it. I've also got an interesting piece of code up here that I didn't get to talk about in the previous example, but I'm writing out at this get type and base type. When you first write this out, it might surprise you what type you get back. We saw it in the decompiler earlier, so we know now, but this is going to return a type of Razor page. So let's give this a quick run. While that's spinning up, I'll answer some questions here. So when I zoom in and out, things get a little slow on the stream. And the question is, how do Telerik controls come into play? It's actually a really excellent question. So there are, we are covering at least 4 different ways of writing HTML within ASP.NET. And for all of those ways that you can write HTML, Telerik has support for those components. We'll take a quick jump over to telerik.com. If we drop down the All Products tab, there are so many different ways that we can write reusable components for MVC. We have the Telerik UI for MVC and Telerik UI for ASP.NET Core. I'll talk a little bit about these again later, so I won't go diving into detail yet. And we also have UI for Blazor, and we also have Kendo UI, which is just a JavaScript framework that works with any flavor of ASP.NET, MVC, or Razor pages. So we'll get into those in a little bit, but let's jump back to our demo here. So this is the result from that HTML helper. And we have our Beer City Code logo. If we inspect, we just have that same string that was written out from our helper method there. So I'm going to zoom in down here in the inspection tool at the bottom, and we can see where we wrote @HTML Beer City. We have our image link with the proper image source rendered out to the screen. So that's how an HTML helper works. And then I also have this in here. We rendered @this. So @this get type base type. And when we render that out, we get Microsoft ASP.NET Core MVC Razor page of type system.object. Let's go ahead and decompile that view. So let's pull up our File Explorer again, and we will jump into that folder. So I'm going to go under bin, debug, ASP.NET Core, and we should once again have our view DLL file. Let's run just decompile, and we'll be able to see our HTML helper in there. So what's interesting about HTML helpers is we use them all the time, and we write the syntax out of @HTML. But wonder how many people know where that HTML comes from. Remember, we're extending iHTML helper. So when we write an extension method, we're extending something. We have to have a type to extend, and when we write @HTML, we're extending iHTML helper, so we have to have an instance of that type somewhere named named HTML that we're accessing with this operator through Razor. So where does that actually come from? We'll actually be able to see that in the compiled view. So if you go under ASP.NET Core, under View Index, View Home Index, and we decompile our index view again, what's really interesting is we're getting some of this stuff generated for us by the compiler. You can see all these Razor inject values here. There's actually a public property on our view named HTML, and that's where the @HTML comes from. Let me see if I can zoom in a little bit on the view here. There's our property that has been injected for us by the compiler. So there's where @HTML comes from. This is the iHTML helper that we extend when we write our HTML helpers. And then when we execute those HTML helpers, this is what they look like. So we can see down here, the method is the rendering method is calling this.write, and then it calls this.html.beercity and executes that extension method. And that's where our string gets generated. Remember, these are all tools that are generating strings. So we're in the main body of the view, we're generating strings. Then we get our HTML helper, that generates a string, and it returns all of these strings out to the view. This builds up our entire view for our index page. So that is an HTML helper. So an HTML Razor view is a view that's returned from an MVC application that is a HTML string. An HTML helper is an encapsulation of a small bit of HTML code that is also returned from a view as a string. Thanks for the follow, W Hawk, was it? Walk or W Hawk. Don't know how you pronounce that, but thanks for the follow. Okay, so we've got HTML helpers and HTML views. And I think my presenter mode is out of sync here. There we go. We've talked about views, helpers. Let's talk about Razor pages. Razor pages are fairly new. They are introduced in ASP.NET Core, and they're a page-focused approach to writing an application versus writing a controller, model view controller. A page incorporates a controller action and routing inside of the page. They can integrate with MVC, so we can use Razor pages and Razor views in the same project. It's a pretty common theme across all of ASP.NET Core is that we can use them in different frameworks. So we can pick and choose the pieces that we like, which is nice. And Razor pages are generally made up of course, HTML. Tag helpers are more typical, but HTML helpers are compatible. And we can also use Razor components if we're on the bleeding edge of things. To get to this template, we choose File, New Project, and select Web Application versus selecting Model View Controller. And some of the major differences that you'll notice is those controllers and models are all incorporated inside of the view, so we have a very flat file structure. So we don't have separation of these controllers and views and models. They're all incorporated in a code behind style presentation. This is what the title of this is incorrect. This shouldn't say custom HTML helper, but rather a Razor page. So this is a Razor page we're looking at. We have the @page directive, which identifies this as a Razor page. We pass in the model, or we have a model directive that explains what type of model we have. This defines our code behind. Then we have our markup. And then our code behind looks like the right-hand side, and this is connected by this class name here. This is our index model. You can see the matching model on the left, and this inherits from the page model. We can set up public properties and fields and use those throughout our code inside of our Razor page. Now, the Razor page has its own controller actions and routing built in, so you won't find a controller that's going to return the index page. Instead, we have these methods that execute on get, post, and other HTTP responses. So, or verbs rather. So we have get, put, post. We have methods for these, and these are prefixed by the word on. So on get, we can set a message and return the current date and time inside of our template. So this only gets executed when the get HTTP verb is executed. So we have these for other types to get and update data within our Razor pages. So let's look at a quick demo of a Razor page. So I'm going to close this solution out. We won't save that. We'll open a brand new one here. So in this solution, I have a Razor Pages application, and it's going to look a little bit different from the solution that we had before with the model view controller folders, because instead, inside of a Razor Pages application, we simply have this pages folder and a structure that contains all of our pages. We have a similar example to what we saw in the slides. We have a page directive that identifies this as a Razor page versus a Razor view. We've identified our model with the model directive. So we have our index model, which is our code behind for this page. We're also seeing the add tag helper directive here. We'll get into that one in a moment, but this is a special directive that is used in MVC and Razor pages to add a tag helper to our scope. And then I'm also calling this .getType base type, so we can see what kind of base type a Razor page is made from. Remember, a view is of type Razor page of T. We'll see what this is in a moment when it renders. We're writing a simple action out using a tag helper. We'll get into tag helpers next, but you'll see that we're transitioning from HTML helpers to tag helpers now because we're using Razor pages. If we look at our index model, I'm going to hold down Control here and right click. That's going to bring me to my code behind. We can also identify that in our file browser over here. If we look under index, we also have an index.cshtml.cs. This is that same code behind model that we're seeing. So index model inherits from page model. And then we have a property called message that we can set a value to. And then when the get method is called, when we call an HTTP get on the index route, this is the message that is set. We could do things like database calls inside of here and display information from a database and do CRUD operations and things like that. We have other functions that we could call if we're doing, for example, gets versus gets. We could have let's see if we can get on should be on delete if we were deleting something and so on. So all of the HTTP verbs are supported there. So let's take a look at what gets compiled from a Razor page. If we go and open up our File Explorer again, we can look at our Razor pages bin folder, debug, properties, or sorry, not under properties, under the ASP.NET, we have Razor pages app.views.dll will decompile that one. So we're going to decompile that page. We'll skip all the dependencies. We don't need to decompile everything attached to this. That's what that dialog box is trying to do. And we'll drill down into the pages namespace, and then we have pages index. And once again, we don't need to decompile everything attached, so we'll skip these references. So this looks slightly different. And what you might find surprising is that with a Razor view, the class type is actually a Razor page. And when we're looking at a Razor page, the class type is actually just page. So an interesting bit about Razor pages and Razor views is they inherit from different class types. One might expect a Razor view or Razor page to inherit from Razor page, but a Razor view does. So that's a little bit confusing, but fortunately for us, we don't really have to be too concerned with what happens after it's compiled. You'll notice it also has a lot of generated properties and fields that get created by the compiler, and we still have our HTML, our HTML helper available, so we can still use HTML helpers, even though tag helpers are preferred in the Razor pages model of development. Another familiar one that you'll see is URL. So when we're looking for a way to access our URL information, we're used to typing at URL. That's something else that gets created by the compiler. And then again, we have our final task that executes our view. And you will see write literal all through creating this view. Now, there's a little bit more complexity behind how this happens in a Razor page because we've got some of our we've got some HTML helpers in here that are writing out some information as well. We'll talk a little bit more about the HTML helpers in a minute, but for all intents and purposes, everything in here is doing a this.write or this.write literal. So all of this is string generation. This is all HTML string generation that's happening in that method. So that is the render method of the Razor page, the index page. I'm going to minimize that. We're going to come back to it in just a minute after we write some tag helpers. So we've got a comment that is about the desktop. So for someone that is on the desktop, Razor feels less intimidating and confusing as compared to desktop, I'm assuming. It's been a while since I've done desktop development, but I remember creating custom components for the desktop was not an easy task. So creating custom bits of reusable markup in any of the ASP.NET ecosystem is fairly easy, and it keeps getting easier, as we'll see with Blazor. So we are going to move on now to tag helpers. So let me find my place in the slide deck here. There we go. So we're talking about tag helpers now. We saw tag helpers being used on our Razor pages. They were introduced with Razor pages in ASP.NET Core. And Razor pages, or sorry, tag helpers are an asynchronous server-side processing of HTML elements. They are similar to HTML helpers, but unlike HTML helpers, they use tags and attributes, which are more similar to HTML itself. So they look and feel and act a lot like HTML versus escaping with an at character, as we'll see in a minute. That escaping eliminates, or the need to escape is missing. So that eliminates the need for us to switch between the mental context of C# and HTML. And I don't have a demo for this, but they are much more friendly for user testing than HTML helpers are. So if we look at an HTML helper versus a tag helper, HTML helper has a syntax that looks like the top here. So we have @HTML, we give it a method name like label, then we pass in a set of values, and here's where things kind of get a little blurry. If we need to set a class attribute or a normal HTML attribute, things get odd because we have to create a anonymous method or anonymous object here. So we create a new anonymous object, and then we have to escape it again because the class keyword is reserved by C#. So we have to escape that with an @ symbol. So we've got a lot of @ symbols and weird braces and things going on just to define a class, CSS class for this label. Now, tag helpers alleviate this. So first of all, we don't have an @ to open up the tag. We just use normal HTML, and we can assign a label just by using this ASP-4 property. And then we can assign a class normally just like we would with regular HTML, and also set the name value as we would with normal HTML. Because for all intents and purposes, this is just normal HTML, but we are modifying it slightly through the Razor engine here with the ASP.NET 4 property. Another side-by-side comparison, Telerik, I mentioned this before, we offer all sorts of tools to help .NET developers build applications. Go back to that page real quick. This is an example of two of our components. The top we have our HTML helper. So this sets up a data grid. And to write out that data grid with an HTML helper, we say @HTML, Kendo, we're going to create a grid of customers. We set the name, and then we pass in a builder that creates all of the columns and so on. And this builds out a very complex HTML data grid. With tag helpers, which is something that Telerik also offers, we can do a tag helper that is much more like HTML, and we say Kendo grid. We specify the columns using an HTML-like syntax, and that creates our grid. So this is a little bit of a preference type of a situation, where which type of syntax do you prefer to write, and what do your coworkers like to write? The output of these is almost identical, and the performance is going to be pretty identical as well. The only difference in performance you may see between these two methods of writing the markup is that tag helpers are by default asynchronous. HTML helpers are not. So we can look back at our Telerik page again. We have the Telerik UI for ASP.NET Core. And if we look at demos, we pull up the demos page, you will notice that if we click on our grid, we have the basic usage here where we write out the source code is all in a HTML helper, but we could also do the same exact thing. If we come to the left, we have a tag helper version of this as well. So we have all of those same capabilities but in a tag helper version. So if you're using UI for ASP.NET Core, you get the HTML helpers and the Razor tag helpers. So you get both flavors of writing those components out. And they produce the same output. Tag helpers also have their own directives, so we can add a scope of tag helpers to our view that we're in, or our page that we're in. We can write out third-party tag helpers. We can also remove things from scope. And we can also set prefixes too. So if we wanted to have a prefix of, say, th, we could add that prefix to anything that is a tag helper in our environment. Some built-in ASP.NET Core tag helpers. We have anchor tags, inputs, a lot of things that deal with forms and images. Forms are especially nice to have versus the HTML helpers. The syntax is much nicer, cleaner, and more familiar to HTML than tag helpers are, or HTML helpers are. And again, we have all of these components for the Telerik brand of tools. It's another tag helper example that shows the power of tag helpers and how they make the markup pretty easy to read. Here we have a date picker that we're able to set a start date and what type of formatting and what value we'd like to set that date picker at. So let's go back to our demo that we ran earlier. So this is our index page, and I've already added this tag helper here called Beer City, but we'll look at how this is built. So let's take this off the page here for a moment and go over to beercity.cs and see how this is created. So we're going to create a custom tag helper. So creating a custom tag helper is pretty straightforward, actually. So what we need to do first is set up a class. Now, unlike HTML helpers, tag helpers are not extension methods, they are classes. So we're going to create a class, and I'm going to call this my custom tag helper. You'll notice that the class name doesn't have to match the HTML element that we write in our page. We're going to inherit tag helper, and we're going to give it an attribute called HTML target element. This is going to be what the Razor engine looks for in our markup to identify that it is a tag helper. So I'm going to name this one Beer City. Again, that's where the presentation was given, was Beer City code. So I've named the tag helper Beer City. That's our target element when we write our HTML. This has a public property called name that's going to allow us to set the name that we want for our name property on our tag helper. And then the tag name, we're going to write my tag helper. The tag mode, it's going to need a matching start and end tag. And what we're outputting is this value here. So we need to write out a span and then pass in our name property that we wrote. And then we're going to write out loves Beer City code and close our tag. The place we do this in is our process method. This is the main rendering method of our tag helper. And that tag helper takes a tag helper context and an HTML or a tag helper output. And this is processed by our Razor page and turned into an HTML string. So again, all of this is generating a string at the end of the day. So if we go back to our index page, now we can write out our custom tag helper, and we get IntelliSense for that. So you can see Beer City, and there's our name property, and we can set our name value, and we can end our tag that way. We can run the application, and we'll see this span get written out from our tag helper. So this is all a means of encapsulating complex pieces of HTML that we want to reuse. So the purpose of HTML helpers and tag helpers is the same. The means to get there is slightly different. Tag helpers have some benefits that HTML helpers do not have, and there's our span element there. HTML helpers can be written against HTML tags that already exist, and we can target just attributes versus taking over the entire HTML structure. And then if we look at our render method again, these are writing out strings. The only thing that is different here is you'll notice that there is a tag helper scope manager. Now, the tag helper scope manager is needed because tag helpers, unlike HTML helpers, have to have scope. This is because they can have child elements. If we go back to our presentation materials and look at the difference between a tag helper and an HTML helper, everything on an HTML helper is being created in line using a Fluent API. So this is one long method call that is being created here. This one long method call creates all of that grid. If we look at the or the tag helper version of this component, we have child components within. So we have the outer grid, and then we have child components inside of it, which are columns in this scenario. So we have to have a context that is aware where this grid begins and ends and what is in between. So that's all taken care of for us behind the scenes, but it is an important distinction between a tag helper and an HTML helper. So that's why you see all of this in the final markup, or the final code that is compiled from our markup. You'll see that tag helper scope manager created for each tag helper that we execute. But those tag helpers at the end of the day write a string, and so does our Blazor page. It writes out a string as an HTTP string response. So that is Blazor pages and tag helpers. I'm going to talk about view components next, but I'm going to save time by not doing a full demo of that. View components are very similar. They replaced child actions in MVC. So in MVC for .NET Framework, we had child actions. Those did not get migrated over to ASP.NET Core. Instead, we have view components in ASP.NET Core. These are similar to tag helpers and HTML helpers in that they render a chunk of HTML. They have some similarities with a controller and a view, so they can encapsulate logic as well that is application specific rather than something that is just for that component. So a good example of something that encapsulates HTML and some logic that is a reusable component throughout the scope of an application would be if we wanted to put a weather widget in our application and we wanted to display that weather widget just by invoking an HTML block instead of writing out very specific code. So this weather widget could on its own make an HTTP call to a service to get weather data and bring it back. So that's a little bit of the difference between a view component and a tag helper, is that they encapsulate this logic on their own, much like a controller and a view does. They can have parameters and business logic, as I try to explain with the weather example. They're typically invoked from a layout page rather than an actual routed page. So this would be something that is used site-wide. And again, that weather component layout is a pretty good example. There was some rumblings that Razor components may replace the need for Vue components. I'm not going to get into details on it, but you may see some similarities between how Vue components and Razor components kind of cross some similar concerns, and you may not need both in the future. This is what the syntax for a Vue component looks like, and you call VC : and the name of the Vue component you would like to invoke. This example is like a tag cloud or something of that nature. So you would list out on your website some information, maybe in a sidebar or something like that, where it's fetching data from a database all on its own. So the Vue component has much more complex logic than just rendering out, say, a data grid or something. So that's Vue components. I won't go into detail of decompiling those. They also create HTML, but they contain other actions like a controller does within them. So let's talk about Blazor next. This is where the distinction between Razor views, tag helpers, and pages and HTML helpers really kind of change. So let's first talk about a Razor component. This name got thrown around for a little while as a server-side Blazor application, but that is not what a Razor component is defined as anymore. So as of today, a Razor component is a component designed for ASP.NET MVC and typically used in the Blazor framework, although they are not dependent on being used only in Blazor. They use the Razor syntax. They have a component architecture versus just being static HTML generators. They create a render tree or a DOM abstraction versus generating strings like HTML helpers do. You could relate them as similar to JSX is for React. Razor components are for ASP.NET. They use the Razor file extension versus the CSHTML file extension. Razor files are used for code generation of .NET classes, and these classes implement a render tree, which is a big separation from how HTML helpers and tag helpers work. Remember, those things just generate strings. They don't have anything to do with a render tree. So let's talk about render trees for a second. What is a render tree? If we take the typical JavaScript or jQuery application, this doesn't hold true for React and Angular. This is just vanilla JavaScript or jQuery. When we do work on our application, say someone clicks a drop-down box, many components may interact and need to update their view state, be displayed, be removed from the DOM, create, read, update, delete, all of those things from the DOM, all of the components on the page interacting together because of user action. Upon each of those interactions in JavaScript or jQuery, those things may get added or removed from the DOM, sometimes even unnecessarily. So what Blazor does to alleviate this expensive task of taking things and manipulating the DOM with them is it creates a shadow copy or a lightweight copy called a render tree. So this is a lightweight copy of the DOM, and it does the work on the render tree first. Once that work is complete, it does a diff algorithm between what is displayed in the DOM and what the render tree represents for the new DOM. Once it's figured out which elements it needs to update, it then only updates the elements necessary. So it does one single DOM update versus n DOM updates that could possibly have happened in the raw JavaScript application example. Blazor itself is able to run on WebAssembly. So Blazor is a new framework from Microsoft that enables developers to build full stack ASP.NET applications that run C# in the browser. This is done with WebAssembly. So in a normal JavaScript application, we write HTML and JavaScript. Those things get parsed, compiled, and interpreted into bytecode. With WebAssembly, we can skip the parse, compile behaviors of the internal browser engine, and we can compile directly to that bytecode. And we can run that bytecode in the browser natively without plugins. Now, because we're compiling outside the browser, we can also choose from a different ecosystem. We can use different languages like C#, Rust, C++, and other things to compile those files. Blazor itself has all of the things necessary to build a SPA or single page application. So we have dependency injection, routing, unit testing, you name it. If it's in .NET or you use it to build a front-end application, Blazor has it. And Telerik is also on board with Blazor. As I mentioned earlier, we support ASP.NET MVC, Razor Pages, Core. We also have a Telerik UI for Blazor. So you can find all of your components that you would normally use in an application from us for Blazor as well. So Blazor is a C# or a client-side web development technology that uses C#. It uses web standard technologies, does not require any plugins. It uses the mono runtime for WebAssembly to run .NET in the browser. And it can use .NET Standard libraries that already exist because it itself is .NET Standard compliant. What it is not a plugin. It is not a rehash of web forms. It is not the next Silverlight, and it is not transpiled JavaScript. This is more of a breakdown of what a typical Blazor application looks like in block diagram form. Here we're loading our mono runtime for WebAssembly. Our .NET DLLs get loaded into that mono runtime for WebAssembly here. This is where our application lives. There's some bootstrapping application, our HTML and JavaScript that get our application up and running. And they also service our JavaScript interop layer. So we can actually call JavaScript methods and C# methods across from JavaScript to C# and C# to JavaScript. So let's do a quick Blazor demo. I will do the Blazor demo here for those who haven't seen it. This may be something that Blazor fans have seen many times before, but what we are going to do is create a new project. We'll create a new web application. We'll choose ASP.NET Core. We'll click Create, and then we're going to choose the client-side Blazor application template and click Create. So there's one last thing that I want to show inside of this compiled behaviors that I've shown with all of the other flavors of ASP.NET MVC. So if you feel like you're pretty familiar with Blazor, you might want to hang on for just a minute. So I'm going to show what that render tree actually looks like. So let's take a look at what the File New Project experience created for us. So we'll run this application. This is what we get out of the box. And there's some nice little Hello World style project examples in here. So we have a counter example and a fetch data example. We'll let this run up. And this is going to run completely on the client side here. So this is a client-side Blazor application, and it is loading up here off screen. Let's bring that over to the main view here, and let's see what happened here. Let's close some of the processes we're not using. Maybe that'll free up some resources here. It looks like we've got a little lag going on. My machine's kind of getting taxed a little bit because of all of the things I have running. Let's see what's happening here. Let's try closing some more stuff out in the background. See if we've got an output here. Oh, we do have that fave icon is missing. That's normal error. Let's try this one more time here. I believe something may have gotten hung up in the background. Let's try running this from Kestrel. It's a little more lightweight. These are all static. It's all a static application that can run completely client-side, but we do, for development purposes, spin up a little web server to host these files out, and there's our application now. So now we've got our hello world. We've got our counter component that we can click and interact with our counter, and then we have a fetch data component that is grabbing some data. So let's look at the counter component very quickly here, and a razor. This is a razor component. This is a razor component running in a Blazor application. The component has a page directive, which is similar to the razor pages model. So there's some similarities there. This also has our route for our component. So we get to this route through the /counter route. We have some simple markup here, and this is HTML and razor markup. And in our paragraph, we're writing out the current count for the counter. And we also have a code block down below that defines the code for the component. And this is all C# code. And you'll notice there's a method handler in here called increment count that when it gets invoked, it creates, or it increments the count field. And that is bound to the onClick event. So this is our button that we click and increment the count. All of this in C#, all running on the client. This is all client-side rendering right here. If we look at this page in our inspection tool in Chrome, and I'm going to pull up the network tab here, and we will reload this page. You'll actually see the project or the application DLL file across the wire here. I may need to zoom out. There we go. There is the .NET DLLs that come over the wire, and this even includes our web application itself. So all of this is .NET running client-side. So that's how we have JavaScript, or C# running on the client without JavaScript. So we don't need to write any JavaScript for our counter component, and neither do we for our fetch data. We're using the familiar @inject directive to do dependency injection to grab an HTTP client. Again, a familiar .NET class if you're using, if you've used any ASP.NET. And then when we load that data, it asynchronously does an HTTP GET and fetches that weather, this time from a flat file, so it's getting it from weather.json file that is statically served from disk, but we could put any HTTP request in there. And one thing that's important to note is this is parsing that data back to a weather forecast C# class and then displaying that on the page. So this is the component model for for Blazor, and this is, in my opinion, going to be the framework that brings .NET forward. And now that we've learned about this, let's take a look at what's happening under the covers, just like we did for the other frameworks that we've looked at. So let's compare our output from a Razor component in Blazor to what is output by an MVC page or MVC view. So Razor pages, Razor views, remember those output a string. So actually I'm in the wrong folder here. I want to go into the OBJ or object folder, and then under .NET Standard, Razor pages, we have a counter.razor.g.cs. This is a generated class. Difference here, let's see if I've got the right one. There are a couple different generated classes that get created. I'm just making sure I have the right one. I believe I do. But this is the difference between the generated classes and the compiled stuff that we saw before. Because I'm looking at a counter.razor.cs file, .g.cs. So this isn't compiled yet. This isn't a DLL yet. When we looked at Razor views and pages, those are compiled into DLLs already. So this is generated code. And inside of our generated code, you'll see that a Razor component overrides a method called buildRenderTree. And a buildRenderTree is not writing a string. It's creating that render tree. So you'll see builder.addMarkup. And this is our h1 tag for our counter. And then we have builder open element, and this is our paragraph tag. So these are not HTML strings. These are actual object representations of the HTML in the render tree. They're also indexed by number. So this sequence number helps with that diffing algorithm that compares these nodes with what is in the DOM and then does the replacement of when a node changes. So for example, if I had some code that removed this p tag from my markup, then I would have a render tree with an index of 0, 2, 3, so it could easily find that the paragraph tag is now missing and reconcile those changes. So this is the code-generated version of that same counter component. Much, much different from a Razor tag helper or HTML helper. This is creating a render tree from its main method versus creating a string. So it's very important to know, because in Blazor, we don't want to manipulate the DOM ourselves. We could essentially call JavaScript through C# and manage the DOM ourselves, but that is going to cause unnecessary overhead, and it is something that is considered bad practice. So that is the major difference right there between Blazor and all of the other ASP.NET Core ecosystem Razor implementations that I talked about. So the last thing I've got here is timeline. We're already in July. We've seen Preview 6, Preview 7 is coming within probably a week or so, and then we're going to have our GA release in September and so on. So we'll have an official release in September of Blazor. This will be the server-side version, and then hopefully we'll see the client side come with ASP.NET Core 5.0, which ships in 2020. So this is still a live stream, so the chat room is open. I will close down some of these windows here and see if I've got any questions that I can answer for folks. Peter says, how do I have enough free time to make all of these shows? How do I have enough free time to make all of these shows? Well, the wonderful thing about this is it's not my free time. It is all sponsored by Progress, the makers of the Telerik UI brand of tools, and the people and fine folks that make our Blazor UI components. They are the ones that support me in the show and allow me to have time to create all these materials and talk to all of you. So hats off to Telerik and the folks at Progress. Let's see here. Blazor Doctor says it's not Silverlight, but it's fair to say that the devs who love Silverlight. It's for the devs who love Silverlight, and client-side Blazor offers what they wanted Silverlight to become. Yeah, I think that's a fair assessment that it has some roots in Silverlight, and it's what Silverlight wanted to be and couldn't be because of the plugins and all of that stuff. So hopefully that was some interesting material. I know a lot of it's probably review for some folks, but it's fun to take some time and look under the hood of what is happening inside of Razor views and Razor pages and see what the compiled code looks like. So hopefully you guys learned something today looking at all that stuff. But the main takeaway there is that the Razor views, Razor pages, HTML helpers, tag helpers, all of those things produce strings. And Blazor does not. It uses a render tree. And that render tree is very essential to how Blazor operates. And that is something that we need to remember when we're developing our applications, is to not go out and modify the DOM unless absolutely necessary. So I'm going to throw some information up. I think a lot of the folks in the chat room here already know, but I'd like to have it on video because I publish all of these videos on YouTube. So if you don't know me or my content, I work for Progress. You can find our tools at demos.teller.com/Blazor. That's our demo page for all of our Blazor stuff. Blazor.net is a great place to start if you're new to Blazor. And then, of course, you can find all of my material through my website at edcharbonneau.com. If you can't remember or spell my name, blazorpro.com will take you there as well. So thank you all for joining me for my presentation today instead of my normal live stream. Anybody have any questions that they want to ask? It's almost, I think this is good material for a show today, so I will probably end it early, and then we'll go on to a normal show on Friday and do some live coding again. We're going to continue our Blazeport application on Friday. Blazeport is our futuristic but fictional Blazor application that lets us book interstellar space travel. So we are getting pretty far along with it. I'm pretty happy with it so far. We're going to be doing some, what are they called again? Cascading drop-down boxes on Friday. So we'll run our Blazeport application, take a look at where we are. I think this might be the last show we get in before Preview 7. We'll have to do some migrations again, possibly next week, but we will see. So real quick, we'll run our Blazeport app and take a look at what we've got. So this is what we'll be working on Friday after some community news. I've got quite a few community links to share on Friday. So it should make a good show as well. But we're going to be adding some functionality to these drop-down boxes. So right now there's only 2. There needs to be 4, so we can select a top level and have a second drop-down box with details up here. So that's what we'll be doing next with our Blazeport application. All right, thank you guys for joining me today on a very special episode of Blazor State Has Changed. So we covered all of the things Razor, from tag helpers to Blazor components or Razor components. The naming is still highly debated, but hopefully by now everybody understands that a Razor component is the component model for Blazor, And also that component model can be used in MVC and Razor pages, which I didn't show yet because it's still in the preview state, I think, and it does work, but we'll save that for another show. Blazor Doctor says, great session. Will help explain to people when Blazor goes live, about inevitable confusion when questions arise between Blazor and Razor. Exactly. I know this is a question we get in the Gitter chat room a lot, so hopefully this clears it up. And I'll put this up on YouTube as soon as I can, so everybody can make sense of all things Razor. McNerdy says, Razor file extension, Razor markup, usable outside Blazor. I hope Razor components sticks. I think Razor, the term Razor components has stuck. So Razor component is the component model for Blazor. Blazor is the framework that is built on Razor components. So when you create your, say, index page or your counter component, those are Razor components, but you're creating them in the Blazor framework. So I think that's the definition that's sticking right now. There was a brief moment in time, the dark days of Blazor, where we called Razor components the server-side execution, and I think that was confusing, and that is going to go away and be swept under the rug for no one else to be confused by. Let's see. Maybe we should raid some folks. Let's see who else is streaming, and we are going to raid. So let's see who is on right now. We have Corey from Twilio is doing a live stream right now. He's got quite a few people in the audience. So let's go raid Corey. He's got about 30 folks. We'll join him in progress, see what he is doing. He likes to cover Blazor quite frequently as well, so we'll go check him out. And thanks again, guys, for joining me on another episode. So get ready to say hi to Corey, and make sure you throw him some Blazor gloves if you've got them. Let's go check him out.